To Doctor and my fellow friends. My name is Akmal Arif bin Mohd Nadzir and my meeting number is 207-573. Okay, as for today, I'm going to present about the topic of differential equation. Okay, for my part, I'm going to explain for partial differential equation and also for homogeneous differential equation. As for the partial differential equation, partial differential equation is a differential equation that contains a partial derivative of the dependent variable which is more than one variable. For example, in the certain equation there will be more than one variable such as x and y in the independent equation. Okay, partial differential equation for x1, 2 as n is an equation of the form. Okay, let's take a look at the example. Okay, the example of partial differential equation. In this diagram, they show one equation. For one is the differential of first order, and second is a second order. As for the third equation, is where the independent one there are more than one variable, which is different derivative of y and derivative of x. This show that this equation is a partial equation. Okay, let's take a look at the homogeneous equation. Homogeneous equation is a different equation that can be homogeneous in either two aspects. For example, one of the equation can be the homogeneous of degree 2, one of the equation can be homogeneous of degree 4. Okay, let's take an example. For example, the equation of fxy equal to x squared plus y squared, where the homogeneous degree of this equation is a homogeneous degree 2, where the highest power is 2. Okay. The below is where the uh, fully equation where it include the z variable. Okay. I think that's all from me. Thank you.
Assalamualaikum and good morning everyone. My name is Muhammad Hazim bin Abdul Rahman and now I am going to share with you about next example. Okay, without further ado, let's look at this example. It says that the concentration of salt X in a homemade soap maker is given as a function of time by dx dt equals to 37.5 minus 3.5x. Okay, given that at the initial time T is equal to 0, the salt concentration in the tank is 50 gram per liter, and using Euler's method and a step size of H equals to 1.5 minute, we need to find the salt concentration after 3 minutes. Okay, looking at the differential equation, we can conclude that this differential equation is a linear differential equation. It is a first order differential equation, and it is an ordinary differential equation. Why it is ordinary? It is because it only involves one independent variable, or we can say it as singular. Compared to a partial differential equation, it must involve more than one independent variables, or we say it as a plural. Okay, so by applying a differential equation in this real life application in chemical engineering, we can compare the exact solution with the numerical solution from Euler's method for the step size of h equal to 1.5 as given in the question. Okay, looking at this graph, we can conclude that at the minute at 3 minute, at the time 3 minute, the value of concentration of salt for the exact value is lower than the numerical solution that we find using Euler's method. So how to find the closer value to the exact value? We can find it by uh, get a smaller step size, which is smaller than 1.5. Okay, so by using a smaller step size, the value will be more accurate, uh, which closer to the exact value. So that's all from me. Thank you.
Hello guys, I'm Shankar. So for the order of differential equation, we are going to see about the Hooke's law. So the Hooke's law is f equals to negative kx. and then the k is a positive constant, which is also called as a spring constant. When we compare it with the Newton's second law, F equals to ma equals negative kx. A is acceleration, which is the rate of change of the velocity, and then v velocity is the rate of change of its position respect to the time. So if we see the acceleration formula, dv over dt, velocity changes over time. Then for the velocity, the formula is dx over dt. So acceleration can be also written as the dx square over d square t, which is the second order of velocity formula. So if we substitute the values into the original formula, m bracket d square x or dx square over d square t bracket equals to negative ks. This is a second order linear equation.